Okay, so we're going to do another example this time, and we'll talk about the activity and the theta value. So first, we're going to put in some clay. Now I've kind of picked these out already. You'll figure out if you pause and look that these work out to a net charge of 4. We're using the same key as before, where green is pretending to be calcium at a +2, blue is pretending to be sodium at a +1, and red is chlorine at a -1.
Okay, hold on. So you're saying that if I add up green and blue, they should equally be on red.
Right. So if what I'm about to do here is I'm going to pair out pieces so that we get net charge of 0. So
Okay.
a blue and a red net to 0 because it's 1 and 1. Blue and red, blue and red. A green is a +2, so it's like calcium. So it goes with 2 reds, and finally 2 reds. I hope that's, if you want, you can pause and check, but you've got a 3, a 3, a 3, a pair, and a pair. So what you find out that what we're left over with is a net charge here in this unit volume of 1 plus 1 plus 2 is a total of, I've done it backwards. It's supposed to be negative. We'll pretend these are all negative. These are chlorines. Here, I'll fix it. 2, 4. There we go. We have a -4 charge.
Right.
So that means that our QV here is a -4, or our QV is 4. Our net charge is 1, 2, 3, 4. So that is the available charge to attract things from the fluid. So this is our cation exchange capacity. So there's a few ways, obviously, that we can fill these in. We can start out with 4 single +1 charges from 4 sodiums.
And their respective chlorines?
No, pretend these are coming out of the fluid. There's still pieces in here, and the charges don't make a huge difference.
So this is within the fuse layer.
Right. So this is in that first layer that's right along there. I just don't have space in my thing. So what we have here is we can consider this like the activity. So here our activity for which is A or Ca, depending on what you're using, is entirely, it's just 1, 2, 3, 4 pieces, and that's for sodium. Now obviously we have no calcium here, so our A for calcium, which is different from this Ca. This Ca is equivalent to activity. This Ca is calcium, the elemental symbol. So our A for calcium here is 0 because we have 0 activity of calcium along the surface. We have no calcium that's attached to the surface. So if we remember that our QV here is 4, so that's the total charge available, or the cation exchange capacity. And our activity here is 4, so we'll find out that theta for Na.
What is theta?
Theta is effectively a surface concentration for this charge. So it'll be the concentration of charge accounted for by the sodiums. So we'll call that's A and A. So the activity of sodium divided by the total charge along the surface, which is QV, which comes out to, as it happens, it's all sodium, so it's 4 over 4, or 1. And obviously, the theta for Ca will be 0
calcium.
For calcium. Sorry, yes, will be 0 over 4 because we have 0 calcium. So the activity for calcium is 0, and the QV for this rock is 4, and so that'll be the theta for Ca will be 0. So we're going to do another example where we take out 2 sodiums and say that a calcium came in here. So now our theta for sodium, that should be a lowercase a, is A and A over QV, which is 2 over 4, right? Because we have 2 charge worth of sodium out of 4 total, which is 1/2, right? And our theta for calcium, which is the activity for calcium. Now, one thing about activity is it's counted in charge, from what I can tell. So the activity for calcium divided by the total charge available is 2 over 4, right? Because this counts for 2 pieces.
Right.
So that comes out to a 1/2. And you'll notice that no matter what we do, because these are just concentrations, and we're assuming there's only two things in the concentration, they always add up to 1, right? So theta Ca plus theta Na has to equal 1, because it's just a two-piece concentration.
Mm-hmm.
So the last thing is, this might be a little trivial, but it's a good explanation. We'll replace our last two sodiums with another calcium, and we'll find out that theta, so this is example 1, example 2, example 3. So our theta for Na, which is the activity for sodium over the total available charge, is now 0 because there's no charge accounted for by sodium, and the total is still 4, so that's 0. And that's a theta. Ca is the total charge accounted for by calcium, which is ACA, which is 2 plus 2 is 4, divided by QV, the total, which is still 4. So 4 over 4 is 1, and now we have our answer, right? And you'll notice 0 plus 1 is still 1, so we're still accounting for charge, total charge capacity, or whatever it's called. I can't remember, I'm tired.
Okay, so we have QV, we have the concept of activity,
Right, activities A.
and we have the concept of theta, which the sum of the two thetas will be equal to 1.
Right.
Good. And we want to thank our sponsor, Dr. Pepper, and of course, M&M's.
Oh yeah.
Say hi.
Hi.